Okay, let me try again to share the screen. All right, this is a little bit optimistic, but I hear that some of you are really upset with the assignment, with the home assignment. So please be honest. Okay, so let's go back to the lecture. I hope that you all read the paper. But before we start, let me just say a few words. The home assignment was not meant for you to answer the tests perfectly well and get a grade of 100 points. The exercise was for you to basically read something not from your own field and see if you can understand anything. I have a solution key and I will post it later on Moodle. And the only exercise in terms of your grade was just to submit something. And obviously, I wanted you to struggle and try to understand. The more you struggle, you learn something new, and the only way to grow is to learn something new. So don't feel bad about not understanding the paper, not being able to answer questions. We just want your participation, that's all. So there was no need to stress out. There was also an issue with Moodle. I'm not used to Moodle. I'm using other systems at UCLA, and when you were not able to put your PDF on Moodle, people send me a PDF by regular email, which is totally fine. Everybody who asked for extension got the extension. So again, we are not sitting here with a stopwatch and trying to fail you. It will be really, really hard to fail this class, okay? So that's about the home assignment. And in terms of the presentation and the 2-page summary of the presentation, the same rule applies. We want your participation. We want you to do the best you can, but nobody plans to fail you on this course, okay? So I hope that removes the stress level, especially now that you all are going to the Pesach vacation. Any questions about this? Okay. So if that is understood, let's move on. But I think I'm hooked here to some kind of a big TV, and I think it gives me some trouble. Let's see if I can flip the slides. Yes. So I want to know if you all read this paper. I don't think we asked this. Let me see. Okay, so you can open your mic and just tell me. I want to have an idea how many people managed to read the paper.
Yes, I read.
Okay. Anybody who did not read?
I did not read the paper.
Okay.
Yeah, me neither. I just looked at it a little, the abstract, but it was a little short notice.
It was a short notice intentionally. And the reason is I did not want you to start to research and figure out, what this paper is all about. And if you notice, I removed the name of the authors and then anything that will identify this paper. In fact, it's very easy to identify and find. So I guess some of you did, but the intention was that you don't. Okay, so I'm going to ask a series of questions about this paper for those of you who read this paper and use Mentimeter to answer. So do the authors state the problem clearly? What is the problem that they try to solve? Whoever put the short notice, maybe you can remove this and just answer this question. Molecular electronic device, yes. Study single molecules. The conduction mechanism. Not clearly. Study single molecules, molecules, energy source. Okay, so you are somehow divided on this question if the problem is stated clearly. I think that yes, the introduction of this paper actually more or less tells us what the authors want to do. Do the authors give a good historical overview of the problem? Short but yes. Yes, with references. So you're not particularly participating today. I would like to have some more participation, but let's move on because we don't have much time. Yeah, I think that overall the introduction and the historical background and putting this paper in context is more or less okay. Do the authors explain well their hypothesis? Yes, they are. Yes. Okay. Do the authors explain well their approach and methods? If it's a theoretical paper, in this case, it's an experimental paper. Yes, very well. Even too much. Do the author explain well the novel contribution towards solving the problem? What's new here? Three-terminal device, self-assembly monolayers, conjugated molecules. Okay. Do the author perform adequate control experiments? Several controls? No. Okay, so these are two conflicting responses. Any other responses? I think there is a reference for a control experiment, but they don't represent they don't present the data of the control experiment. Do the author explain well what was learned? How did they move the field forward? Yes, they did. Yes, in the end. Yeah, so I agree. I think this is the last question. What are the differences between, oh, sorry, that's not related. Okay. So this is a paper we are discussing here. And we went through the list of papers that we set up as we discussed from the beginning of the course, and this is how we want to analyze papers that you will present. So regarding the first question, yes, no previous three-terminal self-assembly monolayer devices. So this is a new thing here. They give good historical overview. They explain that they test for gain in a three-terminal device. And they explain their approach, enough details on 6 organic molecules, device fabrication and measurements. They explain their statistical analysis in a way. They say one sentence, similar behavior has been observed for many devices giving statistical relevance to this data. That was the statistical evidence. No error bars, no how many different devices were tested, and so on. Do the authors explain well their novel contribution towards solving the problem? Yes, they promise molecular electronics on the nanoscale. Do the authors perform adequate control experiments? They do control experiments with non-conductive molecules, but they do not show the data. And do the authors explain well what was learned? How did they move the field forward? Yes, they claim for novel, small, fast, cheap electronics. All right, we used to have 3 more questions that I'm putting aside for now. And I'm showing now data from the paper, from papers. So let me go out of the presentation mode for a second. But how do I do this? No. I think I'm just going to disconnect this display because that gives me trouble. Let's try. Okay. So here are 2 figures from the paper, and what I'm going to do now, I'm going to overlay one figure on top of the other. Everybody can see that? Okay.
Yeah.
And I'm now going to scale. So you can see that 2 curves here agree really very well, except for this area here. And if I change the scale, look at the minus 0.4 volt curve. Now it agrees very well with the other figure. Okay. So that's kind of interesting. And here are some more curves from another paper. And again, let's do this trick. So look at these curves. When I change the scale, look at the minus 10 volts, agrees really well. Look at the first curve, here, that agrees very well. I change the scale a little bit. Look at this curve. They agree very well. Those are figures from different papers, okay? The only thing that is different is the scale. And here is two different figures, presumably on two different molecules. And again, they look very much the same. So that starts the spectacular story of what we call the Sean scandal. Any questions so far? Okay, so I'm going to give you a story. I am not sure I'm going to finish today. We might need half of the meeting after the Passover vacation. I think we have only one of you sign up for that date. And probably I'm not going to finish today, and I'll finish the story next time, but let's start. So this is obviously an example for a scientific misconduct, but it's not just an example. This is an absolutely spectacular example. And just to tell you that this is not, one in a lifetime event like this. This is from Science, 2 months ago, basically, on February 3rd, another suspicion for scientific misconduct, apparently also quite spectacular. So this guy gained prominency in the field of sequencing plants and all kinds of stuff, and he had basically a company that recommended people what they should eat and not eat because of all kinds of things, and he made huge amount of money. And it turns out that everything is fake. So you are invited to read this in this Science issue. So just to tell you that people cheat and falsify and do really bad things in science as much as they do in regular life. So you have people who cheat the IRS, the Mas Haknasa, and you have people who steal from other people. And there is always a percentage of people in the population that will be crooks. And unfortunately, although we try to think about science as a very pure discipline where everybody is doing their job properly, every now and then we find people who really violate everything that we believe in. So we are going to tell the story of Sean. I have a personal touch to this story, as you'll see when we go along with the story. The person who actually discovered this fraud is a good friend of mine, and I witnessed all the things behind the scene even before they were happening publicly. So what I'm going to do, I'm going to use several different resources. You can find actually a lot of the story online, and there are books and there are videos and movies on YouTube, and there are a lot of resources about this story because it's so spectacular. A main source I'm going to use is the memories, recollections of Doug Nathanson, who was a postdoc in Bell Labs at the same time that Sean was. And this is a link to his recount of the events. So basically, he talks about what he remembers being in Bell Labs. Bell Labs changed its name, AT&T Bell Labs Laboratories. It was later called Lucent and then switched back to AT&T Bell Labs. In fact, I did my first year of postdoc over there. The structure and culture. So what he covers in this recollection, he talks about his personal experience, the structure and culture at the lab at the time, the life of a postdoc and a member of technical staff. Many of the postdocs stayed in Bell Labs to become basically scientists, MTSs. Talk about the great successes. That was just in the time where they got the Nobel Prize for the quantum Hall effect. I met Hendrik Sean a couple of months into my postdoc. Sean had come to Bell Labs as a postdoc a few months before me and was working with Bertrand Batlog, who was also the head of the materials physics department. When I met Sean, he was a quiet, nice guy who I say high to in the hall at some rate. He was working in a lab downstairs from Willard's lab, down and across the hall from the communal printer room. He was of medium height, with sandy curly hair, and at the time, all I knew was that he was one of a group of people who would play soccer for a bit on the field outside by the helipad after lunch some days. So he was a very nice guy. People liked him. He was very social. He played soccer. Bertram Batlogg was a very respected scientist, an Austrian with his graduate degree from RTH in Switzerland. Batlogg had done work on a whole variety of strong correlated materials. Bear in mind that there was a fierce competitive, secretive stake to many who came up, I'm just moving these bars here, who came up scientifically through the high TC craze. So we are talking about, a few years after this huge development in solid state physics, which was the discovery of high temperature superconductivity. And every few weeks you had a new paper in PRL or in Science or in Nature on high TC. And this group of people in Bell Labs basically were the people who worked on TC, and now they were looking for the best next thing, and that was molecular electronics. The potential stakes were enormous. If someone could discover a very high temperature superconductor with useful properties. So one of the thoughts was that you could get superconductivity not only in solid state semiconductors, in inorganic crystals of semiconductors, but also in polymer, conductive polymer. You might see some superconductivity. And in fact, Sean published a paper on this. As time went on, it was an open secret that now that his kids were out of school, Batlogg was looking to move back to Europe and had been working on securing a senior position at RTH. As a result, he was traveling quite a bit and was less of a visible presence. And somewhere in there, I'm pretty sure the department leadership was reorganizing in advance for his planned departure. So basically, the story of Sean happens when his direct boss is very busy planning to move from Bell Labs back to Europe. So he is on the line, traveling a lot, talking in Europe about his new position and so on. And he doesn't really pay attention on what is exactly happening in his own lab. The materials in question were waxy and brittle, and making good contacts between metal electrodes and these molecular systems was a bit of a black art. Anyway, data appeared, paper began to be submitted by Sean and company and appearing in print. So one of the main issue about this story is that preparing samples and making contacts to these samples was some kind of an art. And so when people tried to reproduce and didn't get it, initially they believed, okay, he has a better way of, he knows how to put the contacts and so on, and we are not as good as him as of yet. So people were very excited about the results, but it was very, very difficult, or not impossible, to reproduce. Getting a paper out of Bell Labs was supposed to be more difficult than in a university. Draft papers were then sent to someone else in the division, not directly connected to this work. So I experienced this directly myself. Bell Labs instituted an internal peer review before there was an external peer review. So if you had some nice results, first of all, you would present it to your colleagues in a seminar. You would write a draft manuscript and submit it to somebody in the department or outside of the department to read and give you comments. And only when you had those comments, you would go and send it to a journal and then go through a regular peer review. So that was a standard, and that was expected. By late 1999, Sean had been apparently quite productive, producing half a dozen papers over about a year and a half, looking at electronic properties of devices based on clogged single crystals. So there was a collaborator, the name is Clock, and he was an organic chemist making those unique polymers. It sure looked like these materials were going to lead to great things, as the reported results indicated mobilities in the hundreds and climbing with decreasing temperatures an indicator of clean band-like transport. These positive materials properties and shown impressive productivity combined with Batlog's endorsement were enough to net Sean a staff position. So he was very quickly promoted from a postdoc to a staff position, transitioning to an MPS. By this time, the lab had reorganized and Sean was in John Rogers' department. So he moved to another department. By summer 2000, that hiring decision looked like a very good one, as Sean had published a science paper and a nature paper in January and February, respectively, on comparatively conventional semiconductor devices based on crystal of pentasine. In April, he published a science paper reporting field effect modulated superconductivity in devices based on molecular crystal 660. Then something even more extraordinary happened. Sean had a paper appear in Science in June, claiming to have observed the quantum Hall effect in both electrons and holes in field effect devices based on pentasine crystals. This was a remarkable claim for multiple physical reasons. Still, the claimed device performance was amazing. This was also a shock within my part of Mary Hill. This is one of the campuses of Bell Labs. The other campus was in Homedale. I was in Homedale, because this result appeared out of the blue in Science with seemingly no one knowing about it until publication. None of these people had seen the paper before it had gone out, nor had Sean or Batlog given an internal seminar or talk about this. That was extremely unusual. The expectation with Bell Labs was if you have a new result, you first give a talk to your colleagues, then you submit this paper for internal review and only then to the external review. During the fall, the Sean bombshell results started to flood the literature at a rate that even then should have been realizing to be absurd. So he was publishing papers, and we'll talk about this in a second. After this, Sean really ramped up the pace. There was a science paper in July about electronically driven organic laser, not just a light emitting diode, mind you, but a laser. So he was claiming to have a laser from plastic. In November, there was a follow-up science paper with the same author list reporting a light emitting organic field effect transistor. November also saw the published claim that with Hall carriers rather than electrons, C60 could superconduct with a transition temperature as high as 52 Kelvin. This doesn't even count the additional 8 papers that year in journals like Advanced Materials, Applied Physics Letters, Synthetic Metals, and so on. This should have raised red flags for many people. If someone was actually keeping track, it's a level of output that's simply absurd for someone who was allegedly functioning as basically a one-person research group. Basically, in Bell Labs at that time, the groups were extremely small. There was head of the lab, MTS, there was a technician, and maybe a student or a postdoc. This model was later copied to Genelia Farm to do the same type of research culture in biology. But this is how we work. This is how I worked when I was in Bell Labs. Sean did not have a technician. He did not have a postdoc. He didn't have visiting grad students. How was he actually able to fabricate devices, supposedly involving a transatlantic traver for the dielectric deposition? So these devices needed to be put on some support, and he used some dielectric deposition that was only in the University of Constance. So presumably he was taking samples, crystals from Bell Labs, from his collaborators, traveling to Constance, using the evaporator over there, and then flying back and then doing experiments in Bell Labs. That's basically was the story. And measure all of these things, get publication quality data, analyze the data, and write up the manuscript at this rate. So retrospectively, obviously, that was really ridiculous. Batlog had transitioned to ETA full-time by September 2000. Sean published along with co-author Bao another Nature paper in October. This one claiming to have made field effect transistors in which the channel was self-assembled monolayer of molecules. This was followed up by a science paper in December, this one claiming that by substituting molecules into the monolayer, it was possible to discern field effect transport through individual substitution molecules. So he was talking about doping, PNN doping of these transistors. When I saw these papers, I pretty much could not believe what I was reading. The big APS March meeting of condensed matter and materials physicists was in exotic Indianapolis that year. At the meeting, there were all kinds of stories flying around that Sean and Bartlog had been nominated for the Nobel Prize, that Sean had been offered a big endowed professorship in Princeton, that Sean was being considered for a Max Planck directorship, which is really the best you can imagine because you get a big space, many people under you, and huge budget. So this is really a dream position for a scientist. At the same time, no one had been able to reproduce any of the results, even the ones that did not seem to require exceedingly high carrier density. So basically, he was claiming huge mobilities in his plastic crystals, while nobody else had that mobility. So people say, okay, he has better materials, we cannot reproduce because our materials are not as good as his. Sean, however, claimed spectacular on-off behavior far beyond anything achieved thus far with organic materials. His measurement in most cases confirmed various theoretical predictions. The findings were published in prominent scientific publications, including journals like Science and Nature, and gained worldwide attention. However, and again, no research group anywhere in the world succeeded in reproducing the results claimed by Sean. In 2001, he was listed as an author of an average of one newly published research paper every 8 days. So just think about this. It took us years to publish a paper, and he was publishing a paper every 8 days. In that year, he announced in Nature that he had produced a transistor on the molecular scale. The implications of his work were very significant. Basically, he said, I'm going to replace silicon. From now on, we'll make very cheap, very powerful computers with molecules. A key element in Sean's claim, successful observation of various physical phenomena in organic materials, was in the transistor setup, specifically a thin layer of aluminum oxide, which Sean incorporated in the transistor using lab facilities of the University of Constance in Germany. So basically, he claimed that, I guess, between the glass support and the polymer material or of the organic molecules, he had to put a layer of aluminum oxide, and he had to have such specially good aluminum oxide that there was only one place in the world that could deposit this layer, which was in Constance. So he was traveling with his devices to do this deposition over there. Although the equipment and materials used were commonly used by laboratories all over the world, no one succeeded in preparing aluminum oxide layers of similar quality as claimed by Sean. So obviously, all these papers published in the very best journals made huge impact, and they made it to the general media, BBC News. Tiny transistors break new limits. Bell Lab scientists usher in new era of molecular scale electronics. Tiny organic transistors may lead to less expensive and more powerful chips. The molecular scale transistors that we have developed may very well serve as the historical bookend to the transistor legacy started by Bell Labs in 1947. This is Federico Capasso, who was at that time the vice president of Bell Labs, nowadays a very successful and famous professor in Harvard. Superconducting plastic, gate-induced superconductivity in a solution-processed organic polymer film. So this is Nature 2001. First, electronically powered organic laser may lead to more widespread use of lasers for various applications. So these are news releases. magic hands. This is how they call him. 1 paper every 8 days in 2001, 25 co-authors, 6 patent filing, numerous international awards. This is basically a report to the shareholders of AT&T Bell Labs. Hendrik Schon and Zenan Bao teamed with Heng Meng to fabricate molecular scale organic transistors. This work set the stage for a new era of easily assembled and potentially inexpensive molecular electronics that may provide an alternative to silicon-based electronics. So they go to the shareholders and say, look, this guy is going to make us very, very rich. But during this time, AT&T or Lucent are actually having a lot of trouble. They are starting to decline. Lucent stock sales raise questions. Lucent to pay $25 million in SEC settlements. So there are some issues with unfair trading. Suit says Lucent official approved bribery. So Lucent is under the magnifying glass of Wall Street, and they are in trouble, and the stock is diving. And while they promise the shareholders that they are going to be very, very rich at some point because of what he's doing. Any questions so far? Turn on your mic and ask. So let's go to the next.
Yes, I'm just, maybe you will get to that. I'm just wondering right now, I mean, having him publish with more, I mean, with many co-authors, then are they also responsible for this conspiracy? I mean,
excellent question. I deal with this a lot. Okay, so we'll touch on this.
Okay.
Other questions? All right, let's keep on going. So obviously, I prepared the background. We already looked that data is suspicious. This is how we started. But we read this fantastic story of all these papers and news releases and attracting attention from BBC and New York Times. And, everybody is talking about this guy who is a magician who is going to change the world. But you've seen the data is problematic and nobody can reproduce. Soon after Schoen's published his work on single molecule semiconductors, others in the physics community alleged that his data contained anomalies. It started actually with these guys, Su and Lu, who were working on photolithography, and they were collecting all kinds of historical, papers to cite because they wanted to file a patent on their own work. So they originally noticed issues with Schoen's paper describing the assembly of molecular transistors while attempting to patent research on lithography, realizing by accident that Schoen had duplicated figures. So at this point, these two guys don't suspect any misconduct. They just see that in 2 papers, there are 2 identical figures, and they suspect that he just made an honest mistake. And so they bring this to attention. Soon Lu had attempted initial experiments to gather evidence for the patent, but relied on the scientific outcome of Schoen's work. It was not until April 19, 2002, when Lu and Su were meeting with their patent lawyer that they noticed the duplicated data. Another player is Lydia Schoen from Princeton. She noticed that 2 experiments carried out at a very different temperature had identical noise. It wasn't really just Lydia, it was Lydia and Paul McEwen. They were very good friends and collaborators. She was in Princeton. Paul McEwen at that time was in UC Berkeley and in LBL. I just moved several years before that to LBL, and Paul was a very good friend. His lab was 1 floor below mine. We shared the same Xerox machine room, and we talked a lot during lunch breaks. So Paul and Lydia are the heroes of this story. And they come out and they find that totally different experiments have identical data, but not only identical data, but identical noise. And this is really very suspicious because you expect noise to be random. And they've shown that the noise on those two very different papers, very different data is identical. When editors of Nature pointed this out to Sean, he claimed to have accidentally submitted the same graph twice. So basically he said it's an honest mistake. So Paul McEwen then found the same noise in a paper describing a third experiment. I'm not sure that actually Doug here get the full story about who is credited for discovering this. But I can tell you, and at that time, we did not have PowerPoint. We did not have all the tools we now have, but we have a very fancy Xerox machine that could zoom in or zoom out. And we could use that Xerox machine to Xerox transparency. So basically, you would put a piece of paper on the tray and feed in, instead of papers, you would feed in transparencies and you could copy. So what Paul did, he basically took some of Sean's papers, Xerox all the data, all the figures, and at many different magnifications, and then used that to overlay on other papers and basically do exactly what I've done on PowerPoint, showing you the overlap in the data. He did it, by Xeroxing different zooms. By the way, some of the slides that I'm showing you are Paul's slides because Paul is giving a similar talk, much shorter, but he gives a similar talk on this scandal every year in Cornell when he teaches about ethics in science. So more research by McEwen, Liu, and other physicists uncovered a number of examples of duplicated data in Sean's work. This triggers a series of reactions that quickly let Lucent Technologies to start a formal investigation. In mid-May, I got a phone call at work from Bob Willett. He told me that there were apparently terrible problems with several of Sean's papers. It had been noticed by Lydia and Paul that there were clear cases of suspicious figures relabeled in different papers, but clearly the same data replotted. By the way, at that time, Paul is moving from Berkeley to Cornell. To say I was shocked was an understatement, but once you actually look at the figures side by side, there is no doubt at all that there were problems. I found a few more that hadn't been pointed out yet once I started looking, and forward those to Don Monroe, who was serving on the hastily convened investigative panel that Bell Labs put together. So that was Doug's recollection. Here are Lydia, who was actually the one who really came out with all this stuff. Son and her friends felt his data to be too perfect, with many groups failing to reproduce these potentially Nobel Prize-winning results. The uncovering of Sean's scientific fraud would begin with two researchers, Lou and Sue, who noted the duplication of figures in one of Sean's papers while preparing a patent. Around the same time, in April 2002, Sean received a phone call from an informant who has remained anonymous, asking for Sean's opinion on two figures, each in separate publication by Sean, but both appearing to have identical noise. So in fact, Lydia and Paul come to this only after at that time we had answering machines. You would leave a voice message with a tape, and somebody left a message. Until this day, Paul and Lydia don't know who left that message, but that message said, look at this figure in this paper and this other figure in the other paper, and look at the notes. I just happened to check my voicemail message in my office, and I had a very interesting voicemail message, and it said, Lydia, this is your homework. Look at these two papers by Hendrik. And by the tone of his voice, I knew something very juicy was going on. And so I quickly downloaded these two papers, one from Science and one from Nature. Son spotted that the level of noise, which he described as squiggles and bumps, was identical even at the different temperatures, which cannot be possible. Noise should never overlap one another. Noise simply cannot reproduce. After discussion with others, including Paul McEwen, it was decided that Son would inform Nature of this discovery, as her acquaintances all had preprint papers under review at Nature at that time. So basically, Paul and Lydia and a few others were talking among themselves after finding all these problems, but they all had, papers under review in Nature, and they couldn't really apply to the editor and say, look, these other guy papers are suspicious because they have an interest to be published, and this other guy maybe not to be published. So since Son did not have a paper submitted to Nature, it was decided she will talk to the editor. So Son informed Nature via phone call with Carl Zimmerlis, who was the editor. Even before an investigation had begun, Son and McEwen would discover the same issue in 6 of Sean's papers, with the 2 remarking that they had become akin to Mulder and Scully from the fictional TV show X-Files, uncovering the extent of Sean's deception. I emailed Nature, and then they contacted Sean with our claims. He replied that it was an innocent mistake and that he would provide the relevant data. But as we all worked through more of his results, everyone discovered more and more instances of what looked to be fraudulent data, and everything snowballed from there. When a colleague got in touch with Hendrik Sean himself, his only comment was, "How could that be?" Then we sent him the PowerPoint slides presenting our case. We never heard back from him after that. All right, so we talked about his fantastic results and getting up the ladder, becoming famous. We talked about people starting to suspect, and eventually Paul and Lydia, finding the fraudulent data, and all the way getting to the editor of Nature and saying there are problems with these papers. Questions so far? If no, let's move on to investigation. So as we said, in May 2002, Bell Labs set up a committee to investigate. Malcolm Beasley from Stanford is the chair of this committee. The committee obtains information from all of Sean's co-authors and interviewed the 3 principal ones, Bao, Backlog, and Clock. It examined the electronic drafts of the disputed articles, which included processed numeric data. The committee requested copies of the raw data, but found that Sean had kept no laboratory notebooks. His raw data files had been erased from his computer. According to Sean, the files were erased because his computer had limited hard drive space. In addition, all of his experimental samples had been discarded or damaged beyond repair. So no lab notebooks, no raw data files, and no samples that somebody could go and check and measure the same measurement that he did. Sean acknowledged that the data were incorrect in many of these articles. He claimed that the substitutions could have occurred by honest mistake. He omitted some data and stated that he did so to show more convincing evidence for behaviors that he observed. So he even admitted to manipulating data and said, look, I've seen it with my own eyes on the screen of the computer, and I changed the data a little bit to demonstrate what I've seen on the screen. This is the front page of this report by that committee. It's a pretty long report. Here is a table of content. And there is a link. You can actually look at the report yourselves. And here are the 2 figures I showed you. And here they are. They basically, at that time, since there was no raw data file, they digitized those graphs. They generated an Excel sheet with those data points, and they put it, and then they manipulate, and they do exactly what I've done to you with just changing the scale of the figures. And here's what they say in this report. Original plotting data from figure 1 and figure 2 extracted from an electronic draft, replotted to illustrate that the data present in both are exactly the same after dividing the latter by a factor of 2. All but a few of the solid symbols are within the open symbols and agree with each other to 5 significant figures, although they represent distinct data sets. There was 1 or 2 data points that he actually manually changed, such that those 2 graphs are not exactly the same. On September 25, 2002, the committee publicly released its report. The report contained details of 24 allegations of misconduct. They found evidence of Sean's scientific misconduct at least 16 of them. They found that whole data sets had been reused in the number of different experiments. They also found that some of his graphs, which purportedly had been plotted from experimental data, had instead been reproduced using mathematical function. So actually, some of the graphs were just putting an equation in nowadays Mathematica or Python or whatever, and plotting a graph and claiming that this graph is from experiment. The report found that all of the misdeeds had been performed by Sean alone. So they did talk to the collaborators, and they concluded that only Sean had done this misconduct. All of the co-authors, including Batlog, who was the head of the team, were exonerated of scientific misconduct. This sparked widespread debate in the scientific community on how the blame for misconduct should be shared among co-authors, particularly when they share a significant part of the credit. The members of the committee were Beasley, Dagda, Kogelnik, Cromer, and Moron. So this is from the summary. The final allegation can be grouped into 3 classes. Substitution of data, substitution of whole figures, single curves, and partial curves in different or same paper to represent different materials, devices, and conditions. That was one category. The other one, unrealistic precision of data, precision beyond that expected in a real experiment or requiring unreasonable statistical probability. Those are basically curves generated from a formula, and results that contradict known physics, behavior inconsistent with stated devices, parameters, and prevailing physical understanding, so as to suggest possible misrepresentation of data. The committee's main finding and conclusion can be summarized as follows. By all accounts, Sean is a hardworking and productive scientist. If valid, the work he and his co-authors report would represent a remarkable number of major breakthroughs in condensed matter physics and solid-state physics. Except for the provision of starting materials by others, all device fabrication, physical measurement, and data processing in the work in question were carried out by Sean, with no participation of any co-author or other colleagues. None of the most significant physical results was witnessed by any co-author or other colleagues. So he had many co-authors on these papers, but he just got materials from them and decorated his papers with names. But none of those people actually were involved in any of the experiments and basically checking what he's doing. Proper laboratory records were not systematically maintained by Sean in the course of the work in question. In addition, virtually all primary electronic data files were deleted because of old computer, the old computer, he had no space. No working devices with each one might confirm claimed results were presently available, having been damaged in measurements, damaged in transit, or simply discarded. Finally, key processing equipment no longer produces the unparalleled results that enable many of the key experiments. Hence, it is not possible to confirm or refute directly the validity of the claims in the work in question. The most serious allegations regarding the work in question relate to possible manipulation and misrepresentation of data. These allegations speak directly to the question of scientific misconduct. The committee carefully investigated each of these allegations and came to a specific conclusion in each case. The evidence that manipulation and misrepresentation of data occurred is compelling. In its mildest form, whole data sets were substituted to represent different materials or devices. Sean acknowledges that the data are incorrect in many of these instances. He states that this substitution could have occurred by honest mistake. The recurrent nature of these mistakes suggests a deeper problem. At the minimum, Sean showed reckless disregard for the sanctity of data in the value system of science. His failure to retain primary data files compound the problem. More troublesome are the substitution of single curves or even parts of single curves in multiple figures representing different materials or devices, and the use of mathematical functions to represent real data. Sean acknowledges these practices in many instances, but states that they were done to achieve a more convincing representation of behavior that was nonetheless observed. Such practices are completely unacceptable and represent scientific misconduct. One of the most troublesome cases is that the superconductivity of polythiophene. Here, identical curves appear multiple times in whole or in parts in single figure. Sean acknowledges that these data are not valid but cannot explain how they arose. In the view of the committee, it is not possible that this set of curves represent real data, and therefore this is clear, unambiguous case of scientific misconduct. In the end, the committee concludes that of the 24 final allegations examined, Sean committed scientific misconduct in 16, some of which were interrelated. Of the remaining 8, 2 were judged to have no clear relationship to publications, while 6 were troubling but did not provide compelling evidence of scientific misconduct. The committee finds all co-authors of Sean in the work in question completely cleared of scientific misconduct. The committee also finds no evidence that the laboratory practice of the other co-authors in the work in question are outside the accepted practice of their field. In addition to addressing the question of scientific misconduct, the committee also addresses the question whether the co-authors of Sean exercised appropriate professional responsibility in ensuring the validity of data and physical claims in the papers in question. By virtue of their co-authorship, they implicitly endorse the validity of the work. There is no implication here of scientific misconduct. The issue is one of professional responsibility. The committee found this to be an extremely difficult issue, which the scientific community has not considered carefully. Therefore, no clear, widely accepted standards of behavior exist. In order to proceed, the committee adopted, for working purposes, a minimal set of principles that it feels should be honored in collaborative research. At its core, the question of professional responsibility involved the balance between the trust necessary in any collaborative research and the responsibility all researchers bear for veracity of the results with which they are associated. The committee does not endorse the view that each co-author is responsible for the entirety of the collaborative endeavor. The relative responsibility of researchers with very different expertise, seniority, and levels of participation must be considered. So this is the bombshell that you asked me, one of you. And basically the committee says, at this point, 2002, there are no standards to say how co-authors on a paper are responsible for which portion of the paper. The Sean scandal obviously triggered huge changes, and we'll talk about this. And nowadays, when you submit, there are all kinds of questions that you have to answer. This is all coming from this scandal. But at 2002, until this case, nobody discussed what is the responsibility of co-authors. The committee examined this question for each co-author, considering the nature of their participation and the differing degrees of responsibility. The committee concluded that the co-authors of Sean in the work in question have in the main met their responsibilities, but that in one case, questions remain that the committee felt unqualified to resolve given the absence of broader consensus on the nature of the responsibilities of participants in collaborative research endeavor. They don't say this, but I suspect that this one case that they're talking about is probably Batlog, who was a direct boss, who, I don't know, even read those papers. He was really busy moving back to Switzerland and basically did not really supervise the work. The committee gave Sean a chance to respond. So here are some excerpts from his response. Although I disagree with several of the findings of the conclusion in the report of the investigation committee on the possibility of scientific misconduct in the work of Sean and al., I have to admit that I made various mistakes in my scientific work, which I deeply regret. Some of these mistakes might have related to difficult circumstances, and others I did not realize at the time. Nevertheless, it was my responsibility, and there are no excuses for these mistakes, and would like to apologize honestly for these mistakes to the co-authors and the scientific community. However, I would like to state that all the scientific publications that I prepared were based on experimental observations. I have observed experimentally the various physical effects reported in these publications, such as the quantum Hall effect, superconductivity in various materials, lasing, or gate modulation in self-assembled monolayers. And I'm convinced that they are real, although I could not prove this to the investigation committee. Furthermore, I believe that these results will all be reproduced in the future. And if possible for me, I'm willing to work hard on this task, since reproduction will be the only proof of these scientific effects. All right, so he is convinced that everything he reported is correct, but nobody could reproduce it. And guess what? Until today, nobody reproduced Sean's results. Based on experimental observation, I tried to communicate the science that I described, the experimental findings, and that I was convinced of. Although I have made mistakes, I never wanted to mislead anybody or to misuse anybody's trust. I realize that there is a lack of credibility in light of these mistakes. Nevertheless, I truly believe that the reported scientific effects are real, exciting, and worth working for. So basically, to summarize the committee conclusions, only Sean made devices, no co-authors ever witnessed an experiment, no laboratory records were kept, original data was deleted from the if existed, was deleted from the computer, nearly every rule of scientific documentation was violated. Questions so far? That was the investigation. All right, let's keep on going. Let's talk about the aftermath. The final report of the investigation committee was issued in September and still makes a mortifying reading. The short version, despite claims in the intro that by the accounts, Sean was a hardworking, productive scientist, it sure looks like he never actually did any of this stuff. There were no samples. There were no data files. Allegedly because of the hard drive, as we said, and because of limited storage space, a claim so ludicrous that my eyes almost rolled out of my head when I read it. And there was no lab notebook. What about the co-authors? As for backlog, truly that is a mystery for me. In summer 2002, when the story broke, he quickly threw Sean under the bus. The quote, as reported by a New York Times in October 2002, was, "When I'm a passenger in a car and the driver drives through the red light, then I am not to be blamed." So basically, his boss says, I was a passenger in this, and I'm not responsible. Essentially, every person who at some point had nominal managerial responsibility over Sean ended up in academia in extremely prestigious positions, including Backlog, who was now retired. So basically, all the people involved did very well. Nobody accused them of anything. Again, it comes to their responsibility as co-authors, and all the blame fell on Sean. Circumstances at the time within Bell Labs, higher turnover, corporate upheaval, enormous trust in the oversight of the immediate senior figure Backlog, surely contributed to the flux of paper that flew through without normal scrutiny or an opportunity for internal review of concern. So that was done. Here is again about the aftermath, as Lydia remembers. In September 2002, Bell Labs dismissed Sean after finding him guilty of 16 counts of scientific misconduct out of total of 25 allegations, including the duplication, falsification, and destroying of data. Unfortunately, most of the evidence from Sean's experiment were damaged or destroyed, and further attempts to replicate transistor behavior has failed. Raw data has been deleted. Upon news of the retraction of 28 of Sean's publication and his firing, Sean lamented for researchers who had spent time trying to replicate Sean's falsified results, commenting to Nature that she hoped people would learn and move forward from this incident. Son claimed that she lost 6 months of work, although affecting her graduate student at the time. Despite warning that she would be outcast from research community, Son attested that she is first and foremost a scientist, and I felt that someone can't do this to Mother Nature. I felt good knowing that I had done the right thing. So she was a young scientist at that time in Princeton. She was on a tenure track, but not tenure. And senior colleagues advised her not to pursue this because, you know, she might miss on the tenure clock. People will resent what she's doing and so on. But she could not let go. The guy was a crook. And she wants, basically, he offended Mother Nature, as she expressed herself. And she really followed up. So she's a true hero of this story. So these are 5 Nature papers. And here is a whole list. 9 science papers were withdrawn, retracted. 7 Nature papers were withdrawn, retracted. 6 physical review papers were withdrawn, retracted. Altogether, 28 papers were withdrawn, retracted. 7 additional papers were marked as questionable. Researchers at Delft University and IBM have since performed experiments similar to Sean's without achieving similar results. Even before the allegations had become public, several research groups had tried to reproduce most of his spectacular results in the field of physics of organic molecular materials without success. Sean returned to Germany and took a job in an engineering firm. But this is not the end of the story. In 2004, the University of Constance, where he got his PhD from, issued a press release stating that Sean's doctoral degree had been revoked due to dishonorable conduct. Department of Physics spokesman called the affair as the biggest fraud in physics in the last 50 years, and credibility of science had been brought into disrepute. So they take away his PhD degree. He appealed that ruling, but in 2009, it was upheld by the university. In response, Sean sued the university and appeared in court to testify in 2010. The court overturned the university decision in September 2010. However, in November, the university moved to appeal the court's ruling. The state court ruled in September 2011 that the university was correct to revoke the doctorate. And the Federal Administrative Court upheld that state court decision in 2013. And the Federal Constitutional Court confirmed this in 2014. So basically, Sean sued the university for taking his degree away. And it went through all the appeal courts in Germany until the Supreme Court, and that was upheld. In October 2004, DFG, this is the main funding agency in Germany, announced sanctions against him. The former DFG postdoctorate fellow was deprived of his active rights to vote in elections, serving committees, or get any funding. Sean was also unable to serve as a peer reviewer for people who apply for DFG funding.
Can I ask something?
Of course.
Okay, I'm just wondering, I mean, if all the scandal began in his postdoctorate, then why would you revoke his PhD? Because his PhD may hold. I mean, whatever he did in his PhD, he earned it.
Yeah.
Supposedly, right? I mean,
Supposedly.
unless you can prove otherwise.
Okay, but the university was really pissed off with this guy who's such a crook, and they say it's such a dishonor that he should not really be having a title from our institution. And guess what? If people started to go back to his PhD, and guess what?
Oh, okay. So
Right.
it seems like he was fraudulent back then, even?
I think he was sick because he was truly believing that everything he is publishing is correct.
Okay, that's a different story. But
He
if
did
his
not
work was
follow
legitimate
the
in back
scientific
then,
We talked a lot about the scientific method, about the replication crisis, about many different things, about notebooking, about, none of that from the very beginning. The story is so fantastic that it made into a book, Plastic Fantastic, $33, so you can purchase it on Amazon. Highly regarded science journalist recounts the case of wonderkind the physicist Hendrik Schon, who faked the discovery of new superconductor at the world-famous Bell Laboratories. Many of the world's top scientists, scientific journals, and experts, including Nobel Prize winners, supported Schon only to learn that they were the victims of the biggest fraud in science. What drove Schon, by all accounts, a mild-mannered, modest, and obliging young man to tell such outrageous lies? Bach dives into the riveting world of science to examine how fraud perpetuates itself today. Schon's rise and fall will be an essential and fascinating account of the missteps of the scientific community for years to come. And that prediction, when the paper was written in 2009, is absolutely correct. Since this amazing case, we had so many changes in rules, and we are still, as we said several times, doing experiments, how to do science better. But this story really shocked the scientific world. So we talked about the book. This is a comment about the book, The Dark Secret of Schon's. There was a BBC documentary. He was initially in BBC for the fantastic result, and then this outrageous story also shown up in BBC. And obviously, as you are all asking, who is at fault? Co-workers, managers, journals, peer review, community. This is Paul's slide. I mean, it's a very complicated question. And obviously, all of this, to some extent, the investigating committee is basically claiming that only Schon is responsible, all the rest did not do anything wrong. That's probably true, but I'm not sure that they did everything right. And doing everything right is a topic of our course, and basically all the changes that happened in scientific publishing ever since. The scandal provoked discussion in the scientific community about the degree of responsibility of co-authors and reviewers of scientific articles. So you probably now know many of the journals ask to list what is the contribution of each co-author to the paper. This is a result of this scandal. The debate centered on whether peer review traditionally is designed to find errors and determine relevance and originality of articles should also be required to detect deliberate fraud. We as reviewers for peer review are not expected to get a paper which is fraudulent and detect this. This is not our job. We assume that everybody who submits a paper did honest job, and we just need to check the paper to see that they followed the scientific method, that they don't have outrageous claims, that every claim that they have is supported by the data, and give comments and maybe make the paper better. As I told you before, even that is in question nowadays because there is no proof that peer review actually results better papers. In fact, There isn't even probably a proof that it's not really highly correlated at all. And we should do better than just what we do nowadays in peer review. But peer reviewers are not supposed to look for crooks. What is the responsibility of the co-authors? What is the responsibility of the mentor, the PI? What is the responsibility of the reviewers? This all opens fantastic questions, and we don't have good answers. Following the scandal, the American Physical Society issued new rules stating that co-authors should be accountable for important data in papers they sign off. So you cannot be just a co-author and have your name decorate a paper. You actually need to read it, ask the main author questions, feel comfortable with this. So here, this is immediately 2002, after the scandal. Already there are new guidelines for professional conduct. This is by the APS. National Academy of Science comes up with comments. First, researchers have an obligation to honor the trust of their colleagues' place in them. Second, researchers have an obligation to themselves. Third, researchers have an obligation to act in ways that serve the public. It all sounds very common sense, and we hope that all scientists follow these simple rules. But every now and then, and I've found a case from 2 months ago, well, found 2 months ago, it's probably ongoing for many years. People cheat. And why do they cheat? What is the motive? We'll talk about this. I think not today, because we are starting to run out of time, but next time that we meet, we'll discuss what brings people to do those things. And the most important question in this whole course, in my view, is how to make sure it doesn't happen to you. Even if you don't have any ill intent, some people are so driven by their ego and they have to be, at the top and get the Nobel Prize, and they're really working just to get there. And they will do everything it takes to get there. So that could be a motive. I think that Sean had a different motive, but we'll discuss this. But some people have mistakes and then they have to retract their papers, and the mistakes are honest. So I'm not asking how to make sure that you are not a crook and you are not going to do what Sean did, but how to make sure you don't have major mistakes that you then later on need to retract. So I think that's what should bother you as scientists. If you want to read more about the Sean scandal, there is a big section in Wikipedia. Lydia Son recollection, Doug recollection that I used here. And there is a YouTube video series. There are 3 movies you can follow. And these are the links here. It tells the whole story. I want to finish just by touching on another kind of a story, but it's not as famous of a story, but I find it to be absolutely fascinating and with very, very different conclusions. And the play out of this story is very, very different. It's very recent. And then we'll stop there and continue the discussion when we meet after the Passover vacation. So this whole issue of retraction, I want to skip this and we'll go over this next time. I just want to tell this story. This is the Nobel Prize in 2018, sorry. This is for molecular evolution to develop better enzymes, and Frances Arnold from Caltech is one of the laureates. She published a paper, and the paper is published in May 2019. It was submitted to the journal, this is the Science. It was submitted just before she got the Nobel. Or during, maybe she was announced, but the ceremony is only in December. So I'm not sure exactly when it was submitted. It's probably written on the paper. And that paper had to be retracted. So in 2020, she retracted this paper. And here is the retraction after publication of the report, site-selective enzymatic, amidation of synthesis of diverse lactams. Effort to reproduce the work showed that the enzyme do not catalyze the reaction with the activities and selectivities claimed. Careful examination of the first author lab notebook then revealed missing contemporaneous entries and raw data for a key experiment. The authors are therefore retracting the paper. In fact, this paper by Arnold has the same story. No notebook, no raw data, experiments cannot be reproduced. But the outcome of this retraction is very, very different. So she's using Twitter, January 2nd, 2020. For my first work-related tweet for 2020, I'm totally bummed to announce that we have retracted last year's paper. The work has not been reproducible. So immediately, when she finds out that the work is not reproducible and the student or postdoc doesn't have a notebook and cannot show her the data, and mind you, when all of this coming out, she was busy. She was busy with the Nobel Prize, but she retracts because she doesn't trust the student anymore.
The difference was she'd already made it to the top.
Yeah, she already made it to the top.
She had more to lose. She had more to lose by going through
Okay,
with it.
but I would argue that most scientists will do what she did. You don't have to get a Nobel Prize to do what she did. It is painful to admit, but important to do so. I apologize to all. I was a bit busy when this was submitted and did not do my job well. Bit busy, meaning I was, preparing for my speech in Stockholm. So she did not have good enough oversight during that time. And the guy went ahead and submitted and immediately replies on Twitter. People praise her for being honest. So the outcome, good for you. Retracting is part of doing good science. You are doing good work and setting an example. I was in the middle of the Nobel Prize hoopla and did not pay enough attention to this submission, so it's my fault. So she takes full responsibility. Let me remind you, when Sean was faced with the committee conclusions, he was basically saying, I've seen all of this. I just wanted to convince people in these results, but I cannot really show the data. So he was never saying that he was falsifying data or he was wrong in any way. So, and Francis Arnold is not the only Nobelist to retract papers. There are many other examples. The willingness to admit mistakes publicly sends a message of trustworthiness and to fellow researchers. So that obviously made it to the news as well about the retraction. And food for thought, and that's what we'll do after Passover. Results were not reproducible, lack of notebook documentation, missing raw data files. Why this case is so different? All right, let me unshare. That was today's story. I have to run to the airport and catch a flight. If there are some burning questions, open your mic and go ahead, but the real discussion will be happening after the Passover vacation. And again, the intention of the homework you got this week was just for you to try to read and understand. I just want to get a PDF from you, that's all. There is no fail in this course, okay? Any other immediate important questions?
I don't know if it's important. I'm just wondering. I mean, it is different, very different from the Sean case because, as I understood it, she was just a co-author. She didn't do the work.
She was a PI.
She was the PI. She didn't. I mean, the experiment was done by one of her students, right? So.
Yeah. But this is, again, so that's the same responsibility or no responsibility for backlog. Same issue.
Yes, exactly.
Okay, her position is the backlog position, and she takes the responsibility. She retracts. She says, I'm to be blamed.
But as a PI, how can you know exactly what's going on in the lab? I mean, as far
as... Excellent. That's what I would like to discuss. because I'm terrified every day of my scientific life that one student will do something that I will then later regret, because I have no means to really go over everything that they do. It's a culture that you instill in your students that plays the role here. If you have the wrong culture, it will come and bite you back.
Yeah, so it's very difficult.
It's extremely, all these topics that we are discussing here, there is no, right and wrong. It's gray. It's all gray area, and it's very difficult. On one hand, you don't want to mistrust your collaborators. They are your friends, and you want to trust them. So you want to show that trust. On the other hand, you want to somehow make sure that what they give you is, you can trust it.
I mean, I just thought that maybe even if she had time to review the paper, she could have still signed off and say, okay, I think it looks good.
But the best thing which I felt to do is meet the student every week, look through his lab notebook and ask him hard questions.
Yes.
Okay. She did not have time to do that.
Okay, thank you.
Okay. Any other questions? Okay. So I wish you all happy Passover, and we'll meet immediately after the vacation. I will just conclude. I'll probably take, 20 minutes to finish. And I think one of you is already signed for that date. And from this point on, you guys are going to do the hard work, and I'm going to sit down, enjoy, and listen. Okay? So again, Chag Sameach, everybody, and I'll see you in 3 weeks.
Chag Sameach, Nisha Tova.
Thank you.
Bye-bye.
Thank you.
Bye.